For the first toolpath, we're going to rough out the part using Surface High Speed Area Rough. Surface High Speed Area Rough toolpath is designed to machine standing bosses and cores, cavities and pockets, or material that other toolpaths left behind. From the status bar, we're going to make sure that we change our main color or wireframe to a dark blue. Come up to the top and select Create, hover over Arc, and select Circle Center Point. We're going to make sure that the diameter of this circle center point is 4.25 and hit Enter on our keyboard, and select the origin here, and select OK. The purpose for doing this before doing our toolpath is now we have a containment boundary for our tools. So, with this done, come up to the top and select Toolpaths, hover over Surface High Speed, and select Area Rough. Mastercam will prompt you to insert an NC name. I'm going to leave mine the default tutorial number 5 and select OK. Mastercam then asks us to select the drive surface. Come over to the right hand side and select QM Surface and hit Enter on your keyboard. As you can see, we have 160 entities that are selected. Select the containment boundary and select the circle that we just created, and select OK and OK once more. As you can see along the right hand side, our chaining options will be located here. Make sure that Area Roughing is selected as well. Come over to the far left hand side and select Tool. Select Library Tool and Filter. We want to make sure that we have the full end mill selected and a tool diameter equal to 0.5. Once we have this, select OK and grab tool number 345 here with a corner radius of 0.0625. Select OK when done. Our tool will be listed in our toolpath manager here. Under the comment, insert rough out the part. You can also adjust your feed rate, spindle speed, plunge rate here. Come up to the top and select your tool, and select Feed Speed Calculator here. You can edit the parameters until you get the desired results, and then you could save them and create new material or tool definition. So if you're happy with this, just select OK. Once this is done, come over to the left hand side and select Cut Parameters. Under Cut Parameters, make sure that these align to your training tutorial. Mine look good compared to my training tutorial, so what I'm going to do is I'm going to go to Tool Containment. Under Tool Containment, I'm going to make sure I compensate to the outside, and I'm going to add offset distance to the tool radius. Adding offset distance to the tool radius will allow an incremental value, i.e. the offset distance, to the tool radius. Using this option will ensure that the tool is always clear of the tool containment boundary by the offset distance. Come over to the left hand side and select Transitions. Under Transitions, make sure plunge rate is turned on, and these values align to that of your training tutorial. I of course need to change my skip pocket smaller than to 0.55 and hit Enter on my keyboard. The radius value up here should also be 0.25 and hit Enter on your keyboard. The radius value sets the radius of the helix as an absolute value. Once this is done, come over to the left hand side and select Linking Parameters. Under Linking Parameters, again make sure that these align to that of your training tutorial. I don't have mine aligned, so I'm changing this to Minimum Vertical Retract. That will also load up my part clearance, which is 0.15. From here, I will go ahead and select OK when done. My toolpath is now being created, and looks something like this. Once this is done, I'm going to come up to the top and select Backplot Selected Operations. With the machine simulator coming up, I can now select the play button. Once you are happy with this, come over to the side and select Verify. Once Verify is turned on, go to View and select Fit and Isometric to Screen so you can see your part being cut. Once this is done, select Play or End. I'm going to select End to save myself a couple of minutes. When it's done cutting, your part should look like this. Come up to the top and select Close. Come over to the left-hand side and toggle your toolpath display. Come up to the top and select Toolpaths, scroll down and select Stock Model. In Stock Model, we're going to name the stock model Stock After Roughing. We're going to make sure that it is cylindrical stock and set to the Z-axis here. We're also going to select Stock Setup, and our values from when we did our stock setup here will come here. Come over to the left-hand side and select Source Operations and make sure that folder number 1 is highlighted. Once you have this, select OK. As you can see, our stock model is being created. Once this is done, come up to the top and toggle your toolpath display.